Welcome to KlassPM. Now we are going to discuss about the representation of quadratic polynomial. So this is the case 2 situation in a graph. Quadratic polynomial. How should we represent the quadratic polynomial in the graph? See, general quadratic polynomial is we are taking p of x is equal to y is equal to ax square plus bx plus c. So this is the quadratic polynomial we are representing in the graph. See, let us consider y is equal to x square minus 3x minus 4. So this is the quadratic polynomial I am going to represent in the graph. Before going to represent the graph, we need to take the x and values as points to locate the graph. Either it is a straight line or any other graphs we are representing. So here I am taking the values. Here I am taking this is the x value, this is the y value, and this is the x and y values. When we are substituting the values of x, we are having the value of y. See, if we are substituting 0, then 1, 2, and again I am taking minus 1 and minus 2. See, the value of x is 0, the value of y is minus 4, and the value of x is, we are substituting 1, then the value of y is minus 6. How? See, in the previous case we substituted the value of 0 and 1, 2, 3 in linear equation. Here also we are substituting, calculating the values to get the value of y. See, p of y, polynomial y is 0. Then the value means here we are taking p of y x square minus 3x minus 4 is equal to 0. When the value of 0 is substituted. See, I am taking 0 square and minus 3 into 0 minus 4. The value is minus 4. How I took here? This is the way we can get. If we are taking x is equal to 1, the value of y is equal to, see, 1 square minus 3 into 1 minus 4. Then we are having 1 minus 3 minus 4. Then we are having minus 6. Then if we are taking x is equal to 2, then y is equal to 2 square minus 3 into 2 minus 4. Then 4 minus 6 minus 4 plus 6 minus 6 will be cancelled, and the t value is, here we are having minus 6. And if we are taking x is equal to minus 1, then y is equal to minus 1 square minus 3 into minus 1 minus 4. 1 minus 3, and here minus into minus plus and 4. Then we are taking here the value, when we are substituting minus 1, the value is here, see, 0. If we are taking minus 2, y is equal to minus 2 square minus 3 into minus 2 minus 4, and 4 minus into minus plus 6 minus 4. Then here we are having the value of 6, 0 and minus 6 minus 6, like that we are having. So here I am taking minus 4 minus 6 minus 6 0 and minus, here the value is 6. Then I am plotting the points like 0 minus 4 and 1 minus 6, 2 minus 6 and minus 1, 0 minus 2, 6 here. So we need to plot these points in the graph, then we will get a quadratic polynomial. How? See, here I am drawing two axes. Here one is the horizontal and the second one is the vertical. Here it is the x and it is the y. This is the x dash, it is the y dash, it is the 0. We know very well about the values. So here I am splitting the x axis and at the same time y axis in equal parts. So it is not a graph. I am taking here the paper or board or plane as a graph. I am considering here 1 2 3 4 5 and here -1 -2 -3 -4 -5. Here the value is 1 2 3 4 5 6 and here -1 -2 -3 -4 and -6 we are having. So when we are plotting the points, here 1 -4 1 0 and the value here 2 as -6 and 0 as -4 and again we are having the points as -1 as 0 and -2 as here 6. So these points I'm taking A, B, C and here D and here E. I'm taking the points as with the points as to represent to conveniently on the graph. Here I'm taking a 1 and 0 means the value is here we are getting and 2 minus 6 we are having here 2 minus 6 here we are having -6. Then here I'm taking 0 and -4 I'm taking here and next -1 and 0. Then it should be here and -1 0 and we are having here -2 6 means here we are taking. So if we are taking these points, that after joining the points we are having in a different procedure we are having. So it is a one type of curve shape. Let us consider here we are representing this as like parabola. Here it is the upward, this is the downward we are considering here. The parabola should be like this. If we are taking different values, we will get the parabolas like upwards or downwards. So here we are having the parabolas either upward direction or downward direction. We are having the parabolas too, where the value is greater than or the value of a is smaller than cases we are having the two parabolas upward or downward directions we are having in this case. And how can we choose the parabolas where it will be intersect or not? Let us consider in this case. Here I am taking case 1. The graph cuts at x-axis at 2 points, distinct points. The parabola will be upwards or downwards. How it is? See, this is the x and this is the y, and the next one I am drawing here. Here this is the x, this is the y. How can we represent the parabola here? Means one is the upward direction, maybe the parabola will be intersecting in two distinct points on x-axis, or downwards also it will be available here. This is the case 1. So in this case we are having two distinct points, the parabola is intersecting the x-axis. And case 2 we are having one more. So graph touches at exactly one point. Here I am drawing this one here like this. Here it is the x, it is the y. Here y is the x. So maybe parabola will be downwards or upwards, but it will be intersecting at only one point, exactly one point. Here we are taking this one as a and a dash, and here we are taking a and a dash, but here the a and a dash will be coincide in one direction only, in one point only, that is the exactly one point. This is the representation of the second case. And we are having one more case here. So case 3 we are having. So I'm considering here same parabolas to representing the graph here. So here it is x and y, here y and x here, and we know very well this is the origin. How can we represent 0? X-axis completely below x-axis, below x-axis. This is the third case we are drawing here. So here it will not touch any quadrants. So upward direction or downward direction, whatever it we are having without touching the x quadrant. This is the third case. In this case we are having polynomial has 0. Means here we are having second degree quadrant. We are saying means 2 zeros we are having, or 1 0, or 1 non-zero values we are having in this case. So in this manner we can represent the polynomials in two ways. That is, the one is the linear representation of the graph and the quadratic representation of the graph in the polynomial. Thank you.